Okay, my name is Darren Steele, and I teach Math 136 here at Ivy Tech Franklin. I'm going to be trying to do as many videos as I can over the course of the semester. These can be used for Math 136 and other courses, but the pacing will assume a college algebra course. I'll probably go a little slower than we do in this region. I don't have any fancy video equipment. I'm using a computer with a webcam. So I'll be walking in and out of the scene. Things may not look right. This is not a professional publication. So this episode is going to be, or this video is going to be over exponent rules and polynomials. I will be referring to this document. It says polynomials on top. Okay? There are three big exponent rules. Big three rules, as I call them. Number one. X to the 8th power times x to the bth power is x to the a plus bth power. So example 1. If you have 5x squared times 4x to the 6th, that's going to be 5 times 4, which is 20. And 2 plus 6 is 8. Sorry, 2. So you'd be adding the exponents. So you would have 20x to the 8th. Okay? Example 2 is 3x to the 7th times 2x to the 4th, which would give me 6, and then 7 times 4, or 7 plus 4, would give me 6x to the 11th. Okay? So if you are multiplying, you actually add the involved exponents. Division is similar. Okay, so rule number 2, x to the a over x to the b is x to the a minus bth power. All right? Or, if the power down here is higher, you'd use 1 over x to the b minus a. So example 1. 10x to the 7th over 2x to the 4th. 10 divided by 2 is just 5, and then 7 minus 4 leaves me 5x cubed. Okay? Example 2. Six x to the 5th over 4x to the 12th. Well, this reduces to 3/2 like a fraction. The power of x is higher down here, so I would do the subtraction from the bottom, which gives me 3 over 2x to the 7th. So that's big rule number 2. Big rule number 3. X to the mth raised to another power is going to be x to the mth power. So the example that I provided, 3x to the 4th squared. You will square the 3 like normal, so you would get 9. 3 squared is 9. And you're going to take 2 times 4. And you would get 9x to the 8th. Okay, so those are the big 3 exponent rules. There are others, but those are the ones that are the most important for you to do. Okay? So, rule number 4. So other rules. Other rules. Number 4. X over y to the pth power allows you to raise the top of the power and the bottom to the power. So I'm going to go ahead and skip to, you guys can go, well, I'll go ahead and do it both. 3/5 squared would be 3 squared over 5 squared, which is 9/25. So that was example 1. Here was example 2. Two x to the 5th over y cubed. That's going to be equivalent to 2x to the 5th cubed over y cubed. Well, 2 cubed is 8, and then you're going to be multiplying these exponents. 5 times 3, and then down here you're going to have y cubed, which leaves me 8x to the 15th over y cubed. All right? So I'm going to erase the board. I'm going to be erasing the board and picking up at rule number 5. Okay? Exponent rules. Number 5. Okay? X to the negative nth is equivalent to 1 over x to the nth. Or another way of putting it, 1 over x to the negative nth is equivalent to just x to the nth. So basically what this means is you can move the exponent to the other side of the fraction bar and move anything with a negative exponent to the other side of the fraction bar and make the exponent positive. So for instance, example 1, you have x to the negative third, which will be 1 over x cubed following this rule very strictly. Longhand, longer, okay? So if I would treat this as moving it to the other side of the fraction bar and making the exponent positive, this is equivalent to x to the negative third over 1. I would move this to the other side of the fraction bar, and I would have 1x to the positive third. And if I vacate the top at a fraction like this, I have to leave a 1. So this is going to be 1 over x cubed. Of course, if you can recognize how the rule works, you don't have to do all that work. So example 2. 2y to the 4th over x to the negative 5th. We're simply going to move this to the numerator and make the exponent positive. So we would have 2y to the 4th, x to the 5th. We vacated the bottom, so that's 1 if you want to write that. You don't really need to because fractions over 1 are usually not necessary. So I'm going to put this in the normal order, alphabetical. 2x to the 5th, y to the 4th. Normally, in multiplication expressions, the variables are in alphabetical order. Okay? Example 3. 5x to the negative third. Y squared. Well, this is going to be moved, this part is going to be moved to the other side of the fraction bar, and I will have x to the positive third. These two are going to stay right where they are. Okay? And then example 4. Three x to the 5th over 7 y to the negative 4th z squared. So this moves to the other side of the fraction bar and becomes positive. So 3x to the 5th stays where it is, but you will have y to the positive 4th. And then 7z squared is left as is. Okay? Rule number 6. Rule number 6. The square root of x to the pth power is that power cut in half. And a general root, the nth root of x to some power, is x to that power over the n. Okay? So one example I used was the square root of 25, x to the 6th. Well, the square root of 25 is just 5. But we're going to take the 6 and cut it in half, which leaves me 5x cubed. Okay? Example 2. We have the cube root of 8x to the 18th. Okay? Which gives me the cube root of 8 is 2. And then we're going to put the 18 over the 3, and we get 2x to the 6th. All right. Rule number 7 and 8. Rule number 7, you guys can read that on the board. Okay, so rule number 7, or you can read that on the paper, but I'll make it quick. X to the 0th is 1 if x does not equal 0. Okay? 0 to the 0th doesn't exist. And anything to the first power is itself. Okay? Anything to the first power is itself. That includes 0. Okay? So, anything to the 0th power is 1, except for 0. And anything to the first power is itself. Okay?